Before we start the discussion about classes, let's quickly talk about the concept of methods. What are methods? Now, methods are basically a collection of statements. Every time you write one line of your code and end it with a semicolon, that is a statement. A method has a collection of such statements. Now, those statements in a method are only executed when the method is called. That means whenever you have a program that you've written, you have a lot of statements, right? And then you click on the run button. All those statements are then executed one by one. But the statements in the method will not be executed unless the method has been called in your program. And what that means, we'll understand when we look at the coded examples. Now, what do those statements do in a method? In a method, there are some statements. What do those statements do? Those statements perform some specific tasks. And after performing those specific tasks, they return some result. And you might want to use that result in your program. Now, you can specify after the statements have been performed and after the specific tasks have been performed, you get the result, right? You can specify the data type of that result. You can say, from this particular method, I only want a result that will be of integer type. Or you might say, I only want a result that can be of Boolean type. And so whatever you specify, the result will be only of that data type. So it could be integer, it could be Boolean, it could be double, it could be string, it could be anything, all the different data types that we talked about, right? But it could also be void. It can be many other types, but it can also be void. Now, if the return type is void, then the method will perform those tasks. The statements will be executed, but there won't be any results. There won't be any return from the method. Great. So now, keeping these things in mind, let's think of a simple task. A method performs some tasks, right? Or some specific task, right? So let's think of a specific task that we want to create a method for. So let's say we want to create a simple method that performs a simple task. And let's say that task is to calculate the area of a circle. Our task is calculate area of a circle. Now let's say the only thing that you're given is the radius. So our input to the method is the radius. Using that radius, we'll calculate the area and then we'll output something. So our input would be the radius. And the radius, let's say, is of integer type. So we'll only take integer radiuses. All right. So we'll say the data type of this input is integer. Great. The output would be area, right? So that area would probably be double because the formula for calculating the area of a circle is pi r squared. And so when you do that, ultimately you'll get something that is of decimal value, right? So we want the output to be of data type double, right? And this would be our return type. When we talked about here that it will return a result, this is what we are returning from this method. And let's say we want to name that method. The method's name would be, let's say, calculate circle area. Now, this is one word, but you have three different words joined together, right? Calculate, circle, and area, but there are no spaces in between. Whenever we name a method, we don't have any spaces in between, all right? But what we do to make it easier for people to understand the name of the method, we separate out the different words by making sure that the first letter is capital. So the first letter of circle is capital C, the first letter of area is capital A, but the first letter of the very first word is always small because we always start the names of methods with lowercase letters, all right? So this is called camel casing. You know how camels have like this hump. So it's just like that. You have a hump here and you have a hump here, right? So this is what camel casing is. So now we know what the task is. Now we know what the inputs are. Now we know what the output should be. And we also have a good name for our method. So always remember that the name of the method should be something that is very easy to understand, so that once you look at the name of the method, you directly know what this method does. Now, when we say calculate circle area, it's extremely clear what this method does. It calculates the area of a circle. So great, now let's start writing our code. So how would the code look like? Now, at the very beginning, what we do is we specify the output type of our method. So the output type here is double, right? So we would say double at first. This will be the starting of our method code. So we'll say what the return type is at first. Then we'll say what the name of the method is. So we'll say calculate circle area. So we have at first the return type, then the name of the method, and inside first brackets we'll say what the input of this method is going to be. Now the input is going to be radius, right? Radius is going to be our input. And what did we decide? We decided that radius can only be of integer data type. So we need to specify that as well. What's the data type of this variable going to be, right? We need to specify that as well. So this is how we start writing our method. The output return type first, then the name of the method, then the input type, and then the input variable. And after that, our statements, the collection of statements, will be between these two brackets. Great. So inside, what would happen? We will calculate the area of the circle, right? So we want to store that area in some variable. Of course, that area would be double type, double data type. So the variable that we want to store that result in should also be double. So we'll define a double type variable, let's say area, right? So area would be our variable, and double area would be what value do we store in area? The value that we store in area would be pi into radius into radius. So pi multiplied by radius, right? That will be the value that would be stored in the variable named area, which is of double type. Great. Now we have the area calculated. Our task is done. So after that, we return our result, and our result is basically area. Great, so that means that our whole method is done. So let's tie it back with what we learned here. Now, a method is a collection of statements, right? So you can think of these two as the collection of statements. And so these are basically the body of the method. And the body of the method is the collection of statements. We have two statements here, right? And that is the collection of statements that we were talking about here. Great. Now, secondly, we might also think of this whole part as different parts, right? So this would be our output type. This would be the name of the method. This would be our input, right? So again, this is return type. This is method name. And this is input. And of course, this is input type. So that is how your method is constructed. Okay. Now, there's one other thing. Always remember that this is called method signature. This is together these two, the name and the input, together these two we call the method signature. And whenever we want to use this method, we call the method signature. Okay, so keep that in mind, and we'll see example of this when we code. Now, when we're tying it back to this part, we've understood that this is a collection of statements in the body of the method. You see, these statements are only executed when the method is called. So this statement, when you write this whole thing, when you write in your code, this will not be executed. This part will only be executed when this method is called using the method signature. And we'll see examples of that when we are coding. It performs some specific tasks and returns a result. So this is the specific task that it performs. This specific task is what it performs. It multiplies radius with radius and pi, and then it returns a result. It returns this area as a result. And you can specify the type of data it will return, right? So we specified that the return type would be double. Of course, area would be double because this will be a decimal number. So now you know how the method is constructed and what the different parts of the method do and what they mean. One last thing that I would like to mention here is that here you've seen a method that has one input, right? You can have methods that have many inputs, or you can have methods that have no inputs. So you could have some method, let's just say, I'm just not thinking of a name. So some method, and it can have no input. It can have maybe some return type. It could be anything. It could be void, it could be int. And then in there, you might have some statements and then a return statement, return something. And this can also happen when you don't have any input. So when this then becomes the signature of the method. The signature is the method name and no real inputs, but you have to provide the brackets. Now, how would you call that method? You'll call that method using the signature, right? And so where we call that method, we'll see that later. But for now, just understand how to call the method. Now, in order to call the method, what we just wrote was some method, right? So we'll just say some method, and that's it. But remember, some method had an integer return type, right? So whatever result that we get from this will be an integer. Now, if we want to use that integer, we might want to store that somewhere. So maybe we'll say int x equals this. So here, x is a variable which is of integer data type. Now, when we want to store some value in x, maybe we just want to call that method, whatever that method does, and that method's result is an integer type, right? And that return, that result is something that we want to store in x. So that is how we'll do it. Because the return is integer type, we'll define x to be of an integer data type, and then store the result of some method in x. In the same way, if we want to call this method, then we need to use the method signature that's here, right? So again, this actually gives us a result that is double, right? So right now here, maybe how would we call it? Again, where we call it is something we'll see later, but right now we're just looking at how we call it. So if we say double y, let's say, and that is the variable where we want to store the area, right? So we'll say double y calculate circle area. Let's say the radius that we want is 6. So this is how we'll call the method. We'll call the method using this, and then whatever result we get, we will store that in this variable. So that is how you call methods. So what did we see here? We saw that a method can have one input, or a method can have no inputs. But a method can also have many inputs, right? So for example, we might have a method that, let's say, has a string return type, and then let's say the name of the method is just some other method. I'm not thinking of any name again. Some other method, let's say, right? And it can take many different inputs as well. So you can have one input, you can have no input, or you can have many different inputs, and those inputs don't necessarily need to be of the same type. So this method might take an input that is an integer, it might take another input that is an integer, but then it might take actually, I don't want to name them the same, so let's say this is A and this is B, and it might take another input that is a string C. So at that point, you might have some statements here, and then you'll have some return. Maybe because it's an integer output, integer return, maybe you'll get some some string return. You'll get some return string, right? So you see, methods can have one argument or one input, no inputs, or many inputs. And here in these statements, you will use these inputs to do some calculation, do whatever you need to do, and then return whatever you need to return, right? So this shows you that a method can have many inputs. Now, what would the signature of this be, wherever we call it? Because this is returning something that is a string, so we'll probably want to store the result of this method in a string. So let's say we define a string z, right? And in that string, we'll store whatever the return or the result of this method is. So we'll say some other method. And then because the first one is an integer, we need to input an integer here, right? So let's say just, I don't know, 4. And then the second one is also an integer, so we'll say, let's say 3. And the last one is a string, so we'll actually input a string, maybe A, B, C, D, E, F, G, and whatever it is, right? And this is how we'll call some other method. So you see, you're always making sure that the signatures match. The signature asks for the name first, and then an integer, another integer, and a string. That is exactly what you did. The name first, you input an integer, another integer, and then a string. So when the program comes here, it'll find this method first. It'll see this method's name and it'll search for this method, wherever this method is. It'll then come here because it'll find this method here. It'll see that you have input in the correct order. The first one is integer, the second one is integer, the third one is a string. And then it'll go in, do its calculation, do whatever you did inside using these variables, and then return something. And this return will then return here, and that would be stored in Z. So I hope now you understand how methods are constructed, what the different forms of the methods are, and that they can take many different inputs. One last thing, we do not call these inputs. I said input because I wanted to make it easy for you to understand. We usually say parameters. So this is a parameter, this is a parameter, this is a parameter. Here, this is a parameter. Now, here, there are no parameters. So basically, radius is a parameter. A is a parameter, B is a parameter, and C is also a parameter. Right? So we call these parameters. So I think now you know more or less everything there is to know about methods.